The last year I've been developing application development courses specific to defending against exploits inside of applications, specifically .NET applications. Also, I developed a course entitled Testing Web Apps for Vulnerabilities, which was specific to give the tester the intuitive nature and how to look at an application and say, I can exploit this cookie in this way, and go through the misuse of a web application. I was approached to speak on .NET from the hacker's perspective. I have about 50 hours of material that I've come up with in the last year or two, so you can imagine it was pretty hard to digest that down to the 90 minutes that we will have here this morning. So what we're going to cover is basically a checklist, a detailed checklist, but it's everything that is good about .NET that will add to your defenses of the specific technologies and the things that it offers. And then we will also talk about what hackers really like about .NET, the things that actually give them maybe an edge in some cases, and things that you should go take the extra steps to protect yourself against. So first, we're going to cover what hackers don't like about .NET. Then we're going to get into a little bit of risk. It's never good to really cover the good and bad things, tell you what to do and tell you what not to do without covering risk, because how many people here have a deadline? People have deadlines. You have to deploy by this time, or you have to do these things. Well, in those cases, you have to have some type of concept of what risk is, why that risk is important, and how it applies to the problems that exist for security purposes. Then we're going to cover what hackers like. Now, some of the things that are in what hackers like do apply to just any ordinary application, but very specifically, we will cover some of the things, the extra steps you need to go against to do, because as we continue with security, how many people here are familiar with buffer overflow or cross-site scripting, SQL injections? These things are becoming more and more and more. More people are becoming aware of them. They're almost common now for people to secure against them or attempt to do so. So we will talk a little bit more about what hackers are turning to in the aspects of .NET upcoming technologies. How are they going to hack your web apps now that maybe you actually secure yourself against what actually statistically comes out to be about 75% of all exploits against these applications are the basic SQL injections, the cross-site scripting, et cetera. So once these go away, we're going to see a different arena of exploits get taken. And then we'll just go through a quick summary at the end. So what hackers dislike? First things first, buffer overflows. We'll get this out of the way. .NET, internal to .NET in managed code, it is technically not feasible to actually have a buffer overflow occur. Once you take these variable length variables, it's a mouthful, they resize, they auto-size, you can't buffer overflow them. You cannot take a specific typed variable and actually copy just this massive amount of data into it. So in managed code, we see that it's very nice. It just takes care of the problem for us. However, we have legacy code. And how many people here are going to rewrite everything in the last 10 years for your new application? Is anyone rewriting all that legacy code? Seriously, is anyone? For security purposes? So you're going to interface with COM. You're going to write some C++ helper DLLs. You're going to interface with things that don't have the .NET buffer overflow protection. It's very interesting. How many people here think there will be less vulnerabilities probably in the next year of development? Or sorry, less vulnerabilities, less buffer overflows due to .NET? How many people think there will be the same number? I see you. How many people think there might be more? Maybe? How many do we have any developers here that develop specifically for .NET? Do you have the mindset currently that buffer overflows are gone? Is that something that you think or you've heard? It's something I've heard a lot. So people say, hey, .NET, it handles it, managed code. We don't have to deal with it. The developer mindset cannot change from an old application to a new application, specifically one developed with .NET. You have to generally store things into a database, serialize them to a file. You're going to have to know the lengths of these variables anyway. You cannot and should not depend on the current managed code state of .NET to be the sole purpose of your protection against buffer overflows. Does that make sense? Does that make sense? Okay, good. So you have to do the same things you used to do. You have to bounds check everything. All right, so self-resizing variables is how managed code keeps this. Now, it's interesting, if you actually attempt in a compiler to copy a variable length variable into a fixed sized variable, you will get compiler errors. It won't let you do it. I've heard that someone actually has manually typed in the intermediate language to actually attempt to do this by bypassing the compiler and that the runtime as well exceptions and will not let you. So the buffer overflows are secure inside of .NET. If you create an application entirely in .NET, sure, there is nothing to worry about. However, you're probably still going to have to write to a file, et cetera. It's good design, and should, in 2.0, you bring in some nice legacy code, then now you have to go back and add all of that bounds checking again. So it's important to make sure that you always do it. So one thing, why reinvent the wheel of all of the code you have back in the day, specifically for your .NET application, would be for security, not just with buffer overflows, but many other things we're about to cover. But if you do use new code or previously coded modules routines, be sure that you actually bounds check inside of .NET. It's so easy to just say, I have a string, input some information into my web application, user clicks a button, hey, I have this string, and it's just automatically resizing. I don't have to worry about it. You'll see that small to medium companies, a lot of large companies today have taken security very seriously. A lot of the smaller ones are very happy about the quick-to-develop methods that .NET allows. Click here, drag this here, poof, I have a web app. You can access my database. Very small amount of lines of code, and instantly you have buffer overflows and problems there. So, role security. We could talk for about a million years on this. In .NET, in code, you have the ability to actually add role security to your functions, to your classes. You can actually say, I have this user that is authenticated. I take his information. I can actually create a principal object out of that. And then as the principal object is stored locally per that thread, that process, then when you execute your behind code that does things, you know that .NET will actually handle the role security on that for you. What this means is, let's say that I authenticate to your application as a standard user, not as an administrator. Somehow I bypass some security so that I can call or have a function called that is going to perform some administrative task. If you have actually implemented role security, meaning it's going to look at the principal object every time that function or every time that class object is accessed and say, is this person that is currently authenticated to my machine, is he supposed to have access to this object? So you can do authorization at that level as well, which is very handy. It answers a lot of questions. If you want to go the extra step and package, let's say, an API to an administrative functionality, basically encapsulate, say, a bunch of SQL calls that are going to be very, let's say, scary, and you would never want an actual user to be able to do that, encapsulating in something like this is going to give you extra security should the problem occur that someone can bypass your front authentication system or get around the authorization to call that out. So, code access security. Does anyone here use this? One. Everyone should be raising their hands. Code access security is one of the best things that .NET has to offer. It gives you so many benefits. Is anyone here familiar with the fun love virus? Anyone remember that? There was this nice virus that went around and decided it was going to modify kernel, the NT kernel, and also the NT loader. NT loader would check NT kernel to make sure that the file hadn't changed upon loading. But of course, you run into a catch-22 every time you try to do this type of checking. If this file is, make sure that this file isn't modified. What if someone modifies the source file? There's only one step there. If they modify both files, then you're out of luck, which is exactly what happened with FunLove. NT kernel and NT loader were modified. That is where the code originally, back then, actually existed for the final comparison for any security call, meaning access to a file, request for any resource, eventually came down to comparison inside of there. That code was changed so that no matter what the status of the comparison returned, it was always true. So if you were a guest user and you wanted to perform an administrative task, hey, no problem, go right ahead. It was basically 8 bytes that were patched. Now, wouldn't it be nice if when the operating system loaded, it could tell you right away, wait, this file has been modified, we don't want to do this. You can actually, with code access security, one of its features is automatic Trojan detection. So, with the Trojan detection, jumping a little bit ahead of myself, signing assemblies, you actually have the ability to cryptographically assign your code. You're basically just signing your executable. It's part of the build process. You store your key rings in your source safe. So your keys, which are very important, your private key ring, there with your code. And if you assume your code's going to be safe, you don't want people to get that, then your key ring's also going to be safe. So assigning the assemblies gives you the ability to have non-Trojanable code. So mobile code. Mobile code, does anyone have any mobile code? It's using .NET code to actually allow people to execute programs on their machine remotely. How many people here use ActiveX? Not very many people. All right, ActiveX has a simple problem that when you're prompted as the user to actually execute this, it says very simply, hey, here's a certificate. Do you want to trust this party? We're going to install and actually execute this ActiveX control. When you say yes, whatever that ActiveX control wants to do, it can do on your computer right then, given your user permissions on that system per your authorization. Mobile code with code access security, signing of assemblies, will actually give you the ability to give somebody an application over the internet that they download, and they can do very specific checking of that executable to make sure that A, it came from Microsoft. One nice thing is you can actually get an Authenticode certificate from VeriSign, just like every other certificate, and it works the same way. It allows a person to say, oh, this really is from Microsoft, cryptographically. Also, internally, they can set on their machine, I only want your code to access my file system or my registry. You can very specifically allow or disallow these things. Now, one reason that mobile code, you don't see it in use too often right now, is because the default permission settings for this mobile code in XP, for example, is very little to no permissions are actually allowed in the internet zone. So if you were to go surf around with XP, Internet Explorer, unless you know to go and actually enable all of these things inside of your client configuration, you're not even going to see any mobile code out there. So that's one reason why a lot of people don't use it, because the details of telling a user, here's how you go configure this, it's kind of cumbersome to do and easily to mess it up. Key management. Okay, cryptography. Has anyone here done any cryptography with .NET yet? 1, 2. Was it easy? Yes? One thing nice, has anyone here used Crypto API to do anything? Did you find that easy? No? In .NET, to do RSA asymmetric cryptography, it is literally 7 lines of code Of course, this is without your exception handling and all of that stuff. But it's 7 lines of code to actually create your key pair, do everything that you need to do. Save your key. 7 lines. And guess what? You don't have to pass in a million different variables. You say, oh, I have this asymmetric thing. It's system.security.cryptography is the namespace. And you say, poof, I have this RSA. Create it. Here's my bit size. Poof, it's there. Your public and private key. Encrypt, decrypt, export this to XML. Save it somewhere. It's that simple. If you're doing .NET, there is no reason you should not be encrypting everything that you deem as secure information or information you wouldn't want a hacker to get their hands on. Very specifically, I hear it misused so often, I have to cover it so that it's clear. There is a big difference between encryption, encoding, and hashing. Encryption, it's very simple. I have data, I have a key. I encrypt, I need the key to actually encrypt, and I need the key to decrypt. So your data is not your key. You go that route, you encrypt, you store it, you save it, and later on you can pull it back out, but you have to have the key. Encoding, you take the data, the algorithm is the key. If you know what the algorithm is, you apply that to the data, you get your output. You apply it in reverse, and you get your data. The algorithm is the key for encoding. Most encoding methods are just out there. They're for very specific functional uses. Base64 encoding is so that we can display things as text that are actually binary data. Hashing is the data is the key. Now, of course, you need to know what algorithm is used as well, but generally that can be determined. So you have the data, you apply the algorithm, you get your output. It is not reversible. You cannot extract the data. The only way to determine whether a hash is the hash for a specific piece of data is to have the data and hash it to come out with a hash. It's a one-way function. So triple DES, RSA, etc. These specific symmetric and asymmetric algorithms are not hashing. Make that very clear. You want in your applications to hash things that you don't need to remember the source information. You want to encrypt everything that is sensitive. And I know that everyone's going to start throwing things at me because when I say this, you think of your performance as it slowly goes down. I can't encrypt everything. I have this large network and multiple tiers, and I got to send this to the client. But I'm going to give you some good reasons why. You can do that now because it's fast. In .NET, taking small amounts of data and actually creating a symmetrical key and just saying, encrypt this, is insanely fast. And there's no reason that you shouldn't do it now. It's all inside of managed code. The byte arrays, which are what are used here, are self-sizing. It's so easy to do. It's so easy to implement. And I have to commend Microsoft for the examples that exist inside of the SDK. It's very easy to look in there and say, that's exactly how I do it, and apply it to your application. Easy key management. Again, it's easy to export the keys. It's easy to get them in their different forms and store them. So, XML, you can actually get the XML keys. There's functions to just say, give this to me, and it will actually give it to you in a simple form so that you can store it, etc. So basically, a lot of the things that hackers don't like is your ability to take your application, look at your application that you're serving from .NET, and make it more secure, make it more impenetrable. Now, we're going to talk a minute about the things like the inputs, what comes in. But the application itself, right here, we cover, role security. Only allow access to the person that should have access to that object. You should never have multiple roles per person. I know that a lot of people may not like that either. When you create version 1.0 of your application, you will have a perfect design. You will say, the administrator, he has access to everything. And the manager, he has access to these few pieces. And the secretary has access to these few pieces. And the moment you go to version 2.0, guess what you do? You say, well, we need to create this new group, but he needs access to half of these objects and half of these objects. And because we all are on a budget and we all have time constraints, and everyone says, well, we already have all this work already done, everyone says, that'll take us 2 weeks. And what ends up happening is we take this new group that we need to apply, and we just start giving permissions to everybody. Because, well, it makes sense. It's really easy to do. But the moment you do that, your 1.0 product, which was very secure per its authorization rules, now became very unsecure because now the secretaries can access things that they shouldn't. And remember, security through obscurity is no security at all. If you hide a URL, if you hide an object and think no one will ever find that, trust me, hackers will find that. The hacker's perspective is that these things are bad. If you actually use these things inside your application, you will make it very, very difficult for a person to, well, bypass it, Trojan your code, etc. All right. So we're going to talk about risk. Wow, time flies. OK, everyone has a deadline. Everyone has performance requirement. And this is new. Everyone has a security requirement. How many people here now do audits in some type of way of your servers? I mean, you do lockdown testing, vulnerability scanning, et cetera, et cetera. You should do all of those things, of course. But eventually, a manager somewhere is going to make a decision. He's going to say, your dollar's worth this much security. And your risk per the security that you're letting through is going to be this much. The basic idea is you don't protect something worth $1,000 by spending $100,000. There's no need. It's completely pointless. So eventually, someone will make a decision. This buffer overflow, which is a couple bytes, could crash a system. But there's not enough room to actually run arbitrary code. There's actually no room at all. All they can do is go over a couple bytes, and it's going to crash things. That may not be a problem, in which case you might actually let that go. So remember, when we get into the next section, which is what hackers like about .NET technology and just web and internet technology, is you may not be able to protect yourself against some of these because of this problem. You may not be able to make someone believe this really is a problem. And again, I will mention that the risk does apply to the previous section as well. It's always important to know that what you gain by doing some very simple things like signing your assemblies, which is literally one command line prompt, and then you add a little setting into one file, and poof, you're always secure from Trojan from that point on. So there's some things where you can gain an amazing amount of security with very little effort. So what hackers like? I have a lot on information leakage. Now, the information leakage itself is the exposure. Exposures lead to vulnerabilities. If I can see a SQL error, for example, well, I might be able to actually perform a SQL injection. So when we talk about information leakage, this really does lead into almost every vulnerability that can exist inside of .NET app, etc. So the view state. How many people here are familiar with the view state? A few hands. OK, so the view state is a base64 encoded state. When you have an application, a .NET application, and you communicate with it as a client, it will actually send to you, by default, the state of the server-side properties that are dynamic. There's a lot to take in. So the properties that change in code dynamically will actually be propagated. The property themselves will be propagated to the client in a base64 string inside the view state, or that is the view state. If you right-click on a .NET page, go to View Source, scroll down. It's right there. View state, base64 encoded. If you take that, base64 decode it, right there in plain text are the name of the property and then the name of the value. The purpose for the view state is so the server does not have to manage all of this data. It gives it to the client. Obviously, this increases performance on the server for memory requirements. It doesn't have to store this information. The client's going to give it right back the next round trip. However, this is a map to exposures and vulnerabilities, and this is why. You have a big web application. I, as a hacker, decide I'm going to spider your entire web application. I'm going to go look at every page I can possibly look at. I'm going to download that view state, and then I'm going to have a tool actually go and decode all the view states. This can be very easily done. And then that automated process goes through and gives me a list of every property and every current value that exists for every dynamic thing. Now, there's one thing, this is key. If you have a server-side control that's dynamic, most likely it's dynamic because it displays information that the user can edit. It displays information that somebody else can edit. It displays information that changes, which most of the time is the information that people can enter. You enter your username, it displays it over here, which means that every place that you enumerate these properties from is a, hey, over here, try to exploit me. Does that make sense? Does everyone see that? OK, so we're going to jump into data grids real quick, because this is key. You have a data grid. One of the properties is the table name. One of the properties is the database name. I can go on and on here about these. If it is dynamic, which is key, if you have a data grid where you set those static and they never change, then you don't have to worry about it. That information won't be sent. However, if you do have that nice data grid that displays information from lots of different tables, it's that single control, very cool engineering feat. However, guess what? I'm a hacker. I look at your view state. Oh, that's what your table name is. Not good for you. So information leakage with view state is key. You can encrypt the view state. It is possible. You have to ask yourself a very important risk question. Is the risk of giving this information out worth the performance loss, both of either turning off the view state completely, which is going to make your performance on your server degrade some, or I will encrypt my view state. Be careful when you encrypt your view state, because your performance most likely will be worsely degraded than if you just turned it off. Because, has anyone here ever seen a view state from a large data grid? How big was yours? Yeah, I've seen some as large as 650K in a single. I want to go here, and it sends 650K of view state along with it, because that's how much information is on the server that it's pushing off to you. So you can imagine if the server, in just that single session, had to store another 650K, your memory, that's a lot of information per session. However, can you imagine encrypting every round trip, encrypting 650K of information for every user? Now, this may be a good reason to get a nice triple DES add-on card for your server, but this is something that just you need to test on a per instance basis. If you have a small amount of memory, or a small amount of data being sent, encrypting it, it's going to be fast, small amount of data. However, large amounts of data, you will have to determine that. So XML, this is something that's been around forever, and it's becoming just a lot more popular. So XML is very simple, plain text. It's a way to describe data. It's very simple, and most often it's actually transmitted in plain text, because that's what it is. And we'll just send this right over here. So we've actually seen this actually have been exploited in past. Someone goes to a server. The server says, hey, would you like to actually apply for a credit card? Yes. Goes through the process. Hey, 30 seconds later, we'll give you an answer. You've been actually approved for $500. And what happened is it actually would create the final XML document that would be posted to the fulfillment server on the client. And so the client said, OK, great. Sure, I accept that. That's great. intercepted it, changed the 500 to 30 grand, and sent it on its way. Of course, you should never do that type of thing on the client. You can't trust the client. But at the same time, who knows? That could have been intercepted by anyone else and changed. So XML, you have to understand, it's plain text. It's simple, it's nice, it's really easy to use with .NET, but sniffing this traffic generally can lead to amazing information leakage. Has anyone here encrypted any XML information? Nobody. Some applications of fixing this problem is that you can go into specific sections, specific tags, and then encrypt the data that's there, just specific tags. This will allow you to avoid encrypting what could be a very large XML document, which could very much degrade performance. And at the same time, it'll give you the security of encrypting just those areas. Because it's text, again, and you have the ability to change it if someone is actually doing some type of man-in-the-middle attack, or if you're posting XML without session to a web service, etc. What if someone saw that, decided to change some data, post, I'll spoof the IP address, oh, look, there's no authentication. XML can be your worst enemy if you don't understand how to make this secure. You need to encrypt sections that are important, that you can deem as sensitive per your risk analysis, and then you need to sign your XML document. Now, one thing about signing, if you have an XML document parser, you're going to have to pull the signature out, validate your document, and then make sure that your signatures, of course, match. But to do this, you're going to have to modify the XML document. So there's a couple extra steps that actually need to be taken. What you need to do is actually you perform your hash of the data, you sign it, you create your signature, and then at that point in time, you place the signature into the document. You transmit the document.
I was curious, what data are you drawing upon to make a statement that encrypting XML will create performance significantly? What specific facts you're pointing to?
I'm sorry?
What facts are you drawing upon to make a statement that encrypting XML is going to be a performance problem? What specific facts are you or drawing that statement from?
Your question is, what facts is that encrypting XML is going to cause a performance problem?
That's correct.
What's your question? I would say that any time that you perform any extra processes are obviously going to degrade that. But more specifically in the nature of a .NET application on a larger scale, yes, the encryption is fast, and I do suggest that you do it via .NET. However, I think that when you have a large, let's say, 100 users on a system, depending on the type, and this is very much dependent on the situation as well, that you might have to encrypt a large amount of XML data. It could be that case. There could be times when maybe you don't notice much of a performance hit at all.
The statement's more about encrypting large data sets than encrypting XML per se.
In my experience, XML that is transmitted generally is large pieces of data, but I would say, in a way, yes. I mean, you're always going to lose some performance when you're encrypting that, and most likely, if you're actually doing XML constantly, round trips, then you're going to, have to do that. And of course, one of the reasons I say that you have to do that is that information can be changed, and you can't validate it, except that if you can decrypt it, you can validate it. Because if it's changed, you can't decrypt it. The key will not decrypt the data. Any other questions on that? Okay, information leakage with SQL errors. I've seen this more times than I can imagine. I actually participated in a very small pen test for a small flower company. And they didn't really have any money. It was just kind of a, hey, can you look at this? And you would never believe it, but SQL error right there, front page, bam, guess what? SQL injection followed about 10 minutes later. So you have to understand your SQL errors cannot ever be given out. You can't do it. This will make your help desk world potentially a nightmare. Depending on the robustness of your application, you're not going to be able to necessarily say, oh, hey, such and such a weird query failed to your user, if that user could be a hacker. And unless you are in a secure network already, you have to assume that every client that hits you from the internet is a hacker. You have to make that assumption. So with that, NoSQL errors. It's too easy. I'm sure people have heard of David Litchfield, maybe have read some of his papers. It's just too easy to do forensic analysis of these errors, find the data types, the format of your tables, and actually add data, add users, manipulate the system, potentially exploit the entire system. So, and remember, the moment that you have one entrance into your system, you look and you say, that's wrong, that user shouldn't be there. Who added this user? You think, hey, we've been penetrated. Can you trust anything else in that database? Would anyone here trust anything in that database? How can you trust your log files? How can you trust anything? It's been hacked. So understand, SQL errors, you just can't give that out. I've heard of people that just take those errors and they have this nice layer where they map SQL errors to their own error handling, and then they pass that up. That's really about the best thing that you can do. Small to medium companies, this is very, very, very common. It's too easy now to just say, install SQL Server, load up my development tool, create myself a form, a data adapter, create my data table. Great, now I have users can authenticate via my custom authentication. I can store data, et cetera, et cetera. Dynamic SQL, SQL errors, no specific custom configuration. Medium to small companies still do not have the funds or the awareness about this. Okay, web errors. Just common web errors, anything that you give to the user, understand, is giving away information. You would be amazed the things that you can gain from a little bit of information. Now, I'm not sure how many people have seen this example before. The idea is that you as a programmer or developer, designer, an architect, you're going to make logical decisions about what you're doing. You're going to be doing this because it's fast, or you're going to do this because you have a need for this company to come in and connect to you here. Understand that hackers as well are logical. Hackers know just as much about it as you do. They're going to assume that you're going to make logical steps towards a conclusion. So we take a login example. You go, you log into a web page, you enter your name and your password. You can imagine the developer who is coding this said, well, first I need to see if the user exists. So I got to go hit the database. So first he goes and hits the database. The user exists. Then at that point in time, then he verifies the password. Because why would you verify a password, or how could you without knowing the user existed first? It's very logical steps. Because of this, the error handling, it would make sense that the error that is returned after you see that the user is invalid, you would say the user is invalid. Very logical. This still occurs out there on the web. The moment it says user is invalid, guess what? It just became an enumeration function. The web page is an enumeration function for me. I go and I say, why don't you just tell me all of your real valid usernames? And I keep on giving it usernames until I don't see invalid user, until I see invalid password. And now I know I have a valid username. All of a sudden, now I can use it. Again, it comes back and says password invalid. Now I can brute force it. I have a valid username, and now I just have to find a valid password. Hopefully you have some type of intrusion detection system or something that is actually looking for anomalies much like this. Understand that brute force attempts against your network, whether for information disclosure or for just denial of service, these things cannot be stopped from occurring. You can limit the information you give, but you can't stop them from occurring. You can only notice that they are occurring. And you should have someone that is notified upon alarms that are actually set off by your intrusion detection systems. So in this case, you should not say your password is invalid. You should not say, I'm sorry, your user is invalid. You should say your user or password is invalid. So every time you give an error back, you need to say, what information am I giving out? The moment you say user or password is invalid instead, obviously it's such a simple example, the person can no longer use it for just a user enumeration or just a password enumeration function. And how many people here, whether you do it yourself in your application or you use a web app or another application, .NET, that actually requests an email address as your user? How many people? None? A couple? Let's say that I wanted to know if you had an account at sportsillustrated.com, just as an example. And I'm not even sure if they use email addresses as their login. But let's say you did, and guess what? And they didn't say user or password invalid. Very simply, you could go through and enumerate at all of these places and determine whether Bob at something.com was a member of this website or this website or this website. There's many ways to use web errors to gain information. Okay, cookies. I know some of this is not necessarily new and specific to .NET, but this is the hacker's perspective. This is the things that we're seeing that, oh, hey, look, it's so easy to do. Cookies are stored on the client. They are modifiable. As of IE 6.0, and I'm not sure if the very latest patch has changed this, but the creation time and the byte size of the cookie are the only things that are checked. If you actually go and maintain the creation time and change stuff within your cookie, like delete these characters, increase the size of these characters over here, and maintain that byte size, IE thinks that cookie's just great, and then you can send it. So there's ways that you can modify cookies, maintain this, and actually change information. Now, what's neat with doing this is that when you know that a server gives you a cookie, especially if it gives you a cookie with data that you have given the server inside of it, now you have a function to create a cookie of any size that you want. So when you eventually find, oh, if I want to buffer overflow this field from a cookie, okay, what I'm going to do is, first I'm going to go there and put in this valid string, and then when it comes back, I'm going to shrink that down. Then I'm going to increase this other one to buffer overflow that field. I've maintained my byte size, send the cookie back. Maybe it breaks, maybe it doesn't. But understood that they are there and they do exist. So another thing modifiable is the expiration time. Understand you shouldn't depend on the expiration time of a cookie ever, because it is modifiable. If you want to store something in a cookie, I'm not saying that that's bad. In fact, if you encrypt some data and then store it in a cookie, encrypt it, base64 it, toss it in the cookie, send it off to the user. When that information comes back, if you can decrypt it, it means it hasn't changed. Does that make sense to everybody? If you can decrypt it and you know it hasn't changed, do you have to perform 1,000 substring searches on it to test for cross-site scripting vulnerabilities against that string? No, you don't, because you decrypted it and it was successful, so you know that it hasn't changed. So all of a sudden, you encrypt something, which on the server side takes a little bit of processing time. It goes to the client. When you pull it back, instead of spending X number of cycles processing, doing substring searches and testing against this and testing against that, you just decrypt it. And the comparison of doing massive substring searches and removals and replacements, does everyone agree that that's probably going to slow things down? Thoughts? Okay. All right, does anyone here serialize data to the client? Anyone? Anytime that you perform serialization, understand when you come back and deserialize that into your objects, think validation. Always think validation. How am I sure that this data hasn't been modified by the user? How can I be sure that I'm not going to have a heap buffer overflow because I deserialize this and poof, something happens? You must be very careful any information you do give to the client. I need to hurry. All right, URLs. Small companies, the system administrator is often a big part of the deployment process. Larger companies, they more administrate than they do probably a lot of the deployment. If you can look at a URL and you see, for example, company.com, MySQL, or some very specific, hey, this is what product we're using. And then you see lookup, and then you see a number. Does anyone have a problem with that? Does anyone say, I wonder if SQL injection is possible? And this point, tick, bam, error. You have to understand, URLs themselves give away way too much information. The moment that you have URLs in your application, you need to look at them. You need to do analysis of it and be very clear that, of course, you should test your authorization so that these people can't get to these URLs, et cetera. You should also ask yourself, can the presence of a URL give the information to someone? Does your file not found error that you return, is that the same or different from access denied? It's completely different, because if I know something exists, that itself is enough information to potentially say an exposure exists in this case. Whether that is I can attempt to see if you have your latest patches because of a known vulnerability and that, et cetera, et cetera. Understand that URLs are very important. Okay. So does easy to develop mean easy to exploit? This is a really big question. If I do not incorporate security knowledge and processing during development, deployment of all resources, regardless of whether the access to that resource is anonymous or authenticated, is exploitation possible? I kind of just made this rhetorical question here to make it very simple and well known that just because you can say, I want this TCP connection, drag it, put it on this form, that is not necessarily secure. Easy development does not mean easy security. So if you're new in doing any type of security work, understand that you need to really look into the security of every individual object that you use, everything that you do. The more easy that it is, the more you're taking for granted. You need to question everything that exists inside of that, because you just need to. All right. It's more specific. Cross-site scripting. .NET will give you a very, very easy and simple example of cross-site scripting. You can take an edit control, drop it on a form, a label, drop it on a form, a button, drop it on a form. Type in the edit control, have the button automatically refresh the label. You can instantly cross-site script yourself that fast. It is that easy in .NET to do. So you have to validate your inputs. And I actually propose that if you think about the design of your application, you can actually avoid all requirements for doing cross-site scripting validation. The moment you start saying, I got to look for script tags, and I have to validate all these weird things and look for a curly brace here, all you're doing is protecting yourself to today. And tomorrow, when a new cross-site scripting type of vulnerability comes out, poof, guess what? You have to go update your application again. You have to go fix that. If you take the design of your application from the perspective of accepting HTML, and instead of saying, hey user, give me HTML, you present them with options. You say, you can send me an href. And the href, they actually select from a drop-down menu, href. And then they type in some piece of information here. You want to limit, very much so, the type of things that you need to validate. What's neat is that you're not actually going to transmit, the client's not going to actually transmit the text, href. They don't need to. You know that selection 1 index, for example, inside of this list box, selection 1 is href. You know that on the server. You know, because you can check the authorization as well per the index that is sent. So when the client says, my href that I'm sending in is going to be this, you can take that and say, index 1, that's href. Does this user have permissions to submit that? Yes, they do. OK, grab the text, validate it. It's, these characters are my limits. You know at that point in time, OK, here's the extents, the risk that I run. And here's a small design idea that you can take, and all of a sudden you can remove large vulnerability potential inside your application. Okay, so if you can avoid it, be very careful with this. Cross-site scripting is something that makes a corporation look bad as opposed to a standard vulnerability that's hacker sent some information, server dropped off the map. Take cross-site scripting, hacker sends information, server stays running. 3 days later, 2,000 people browse in. Those 2,000 people get hacked from information the server gave them. Which one's probably worse for public consumption? If I were to actually browse to a website and I got hacked, well, whose fault is that? I browsed to the website. Who do you think I'm calling? I'm calling them right now. So you can imagine the public upheaval that would exist for large cross-site scripting vulnerabilities. So, okay. Replay and hijacking. There is some good news. There's some things that actually aren't that hard to do inside of .NET where you can actually very much minimalize replay and hijacking like that. They aren't drop in the buckets like press this checkbox. I don't want to be replayed. I don't want to be hijacked. If we had that, then, well, we wouldn't be talking here about it. HTTP session IDs. You connect to a web application, you get a session ID. That session ID is how the web server, how the .NET server is going to know who you are the next time you come back. So you're going to sit there, you're going to read your document, and you're going to say, oh, I'm going to click this hyperlink. You repost back to the server, and it says, oh, I remember who you are, and then you go on your merry way. Is that session ID linked by default to your authentication? Does anyone have an opinion? Let's say that you authenticate as administrator to a system. I authenticate only as a user to that system. But I can't authenticate to that system. I steal your session ID, say through cross-site scripting or packet sniffing and such. I steal that, and now I go and I turn and I say, now I can authenticate to the system. So instantly, I'm in your session. No problems. Now I'm administrator. But I'm still authenticating only as a user. But the session is what controls that. Does that make sense? What do we need to do? What two things would protect against this? Anything? I'm sorry? Cryptographically sign your session? If the session ID is only being compared on the server, I mean, it's just going to be a comparison. If you were to add some type of control to the client to where the client was actually changing it every time in such a way, but if it's just a comparison, then encrypting it or signing it isn't necessarily going to matter. You're just going to pass it right back. But that does actually start driving down the path of what you need to do to stop this. First of all, you need to bind it to your authentication. When you have a session ID, someone authenticates, you need to say, this session ID is bound to this user. Here goes your performance again, unfortunately. Every time you get someone sends data to you, you need to say, if it's not a new session, here's the session ID. Here's the user that is requesting to use this session, even though you gave this to them. And here is the user that was given the initial session ID. Compare. This way, every authentication that exists, that happens, you also are comparing the session as well. Meaning that on a system that has multiple people that can authenticate to different roles, you cannot have hijacking to escalate privileges. That's all you have to do. Simple comparison every time. Obviously, it is a performance decrease because you have to do that extra processing every round. So, SSL. Let's throw that in the loop. You have an SSL connection to a server. Are you secure from being hijacked? How many people here think that you can hijack through SSL? Everyone raise your hands, because you can. If you do not bind, because the session ID is just encrypted inside your SSL. SSL's up here. You say, hey, I need to send this data. It's like, whoosh, sends it off. And the guy on the other end, he just decrypts it and goes on his merry way of displaying it. When you send that session ID back, let's say I have a cross-site scripting attack at your bank. You go and you log into your bank and you're like, message form, click. There's some script right there. The bank, unfortunately, stored this information, and now it's giving it to you in the context of your secure connection. So as far as your browser is concerned and everything, that script is as good as gold. It was meant to be there. It executes, sends me your session ID. Guess what I do? I connect, I get my SSL connection, and then with tools like web sleuth, etc., I put your session ID in there. Great, go. Now I'm in your session over SSL. So it's important to understand that the type of authentication and the session IDs, these things need to be done every time, which is why we have at the bottom your validation for a person to stop hijacking, is by doing your authentication, your session, times every request that exists. Okay. Replay. Let's talk about replay for just a moment. You send the packet. I see the packet. I say, I like that packet. I'm going to send that too. I drop the packet back on the network. Instead, it's coming from me, but that's OK. Maybe I spoof your IP address, and that hits the server. What does the server do with it? Unless it knows that 2 requests showed up, it's going to do exactly what the first one did. You can eliminate replay attacks, and this is actually something banks implement all the time. You can eliminate replay attacks by having a piece of data that changes every time you go the round trip. So you take your validation, your authentication, your session, you're doing that. Now you take another piece of data, which could be the hash of the username, any variation, but it needs to be something that changes. You send it off to the client. It comes back. It needs to change again, get sent off to the client. And I don't suggest just doing get system time, hashing it, and sending it off, because hackers are going to pick that one up like that. You need to actually come up with a good plan of something that isn't predictable. It needs to be needs to have something of private data that is from this user alone, some type of secret. Maybe it's a password hash and this data, all of that hashed together, and then with some time as a seed so that you change it. So you can't just have some public piece of data. As that changes every time, what you do on your server is you maintain a table. You say, here's the hash that I'm giving this person, and you bind it to the session. This session ID equals this hash. Send it to the client. The client comes back. If the session ID doesn't match, guess what? It's not the first time that that packet was sent. Does that make sense? This request, if it doesn't match, it must be a hacker. The packet comes from the client to the server. Let's say it's the right hash for a moment. I'm a hacker. I see it. I pull that up. I'm like, OK, I like this packet. The client continues to communicate to the server. I say, yeah, I'm going to replay this. I drop it back on the network with the session ID, right? It's going to go in this person's session. It goes, it hits the server. Guess what the server does? Says, this is bad. It can immediately notify the client and say, guess what? I just got a request that you sent me 10 minutes ago. You don't need to save what you got every time. You just need to keep changing the hash. If they don't match, this is a duplicate request or an invalid request. You can say immediately, session timed out. You know that there's a problem. And when you know there's a problem, like any intrusion, that's the first step. Oops, there's a problem. Now we can do something about it. What you should do at that point in time, should you see that, to stop replay, is you should immediately actually disconnect both people. You should just terminate that session right then. Go away. Because at that moment, then the person who's attempting to replay, he's not going to be able to replay. The client should be immediately notified this is what happened. And that gives them the ability to maybe call tech support, report it. There's something you can do about it. Okay, injection into XML and SQL. I'm sure everyone's pretty familiar with injection techniques. Obviously, you have some valid string that's like this, and somewhere in the middle here, I'm going to have a variable. And that variable, when it's expanded to its true value, the variable, when it's expanded to its true value, is going to have the final, this is the command I want, or this is the data that I intend to send. And if it's potentially possible for a person to, with XML, instead of just typing in, here's the SKU that I want to do a lookup for, if they say left then, right then, if they start entering their own block of XML, they might be able to make requests based on the validation your server does of those requests. You might be able to make requests for unauthorized data, etc. Dynamic SQL, don't do it. I know it's fast, it's easy, and arguably, I've had this argument with too many people, there are potentially some things that you have to use dynamic SQL to do. I'm not going to say one way or the other that that's true or that's not true, but just say that it's still in discussion. If you do everything, stored procedures, you have your SQL inside of there, you have your stored procedures, you call your stored procedures with .NET SQL command objects, you use SQL parameters, and you actually add a parameter for each, you set the value for each, you will immediately say, that's funny, all my SQL injection problems just went away. Because SQL parameter objects bind the data. You have to tell it exactly the size of your values, you have to tell it exactly the type, and once you do those things, and you perform your stored procedures using these objects, SQL injection goes bye-bye. Did everyone get that? Enter all the ticks you want, enter whatever you want, it just goes away. Now what's neat is the moment you get into this and you say, okay, I got to create some parameter objects, you're going to see that you have potential memory problems because you're creating all of these objects every time you want to access the database. You have performance and you have database, or you have code inflation because you do so much of that. What you can do, and I've actually talked to some people who do things like this, is you have your database here. You know exactly the format, you know the stored procedures, you have your authorization in place, you have your roles in place. When your application starts, it hits the database and it actually caches. You actually create, very specifically, a command object for each stored procedure. Obviously, there might be times for performance reasons or for memory reasons where you would or would not want to do this. You go and you create all of that ahead of time. We have seen as much as 100 to 200% improvement in performance alone just because you have all that cached. You don't create your SQL parameter objects on the fly all the time. They're just there. All you do is you say, store this to the database, and that sets your value, stores that in there. Great, go do the stored procedure. And it just goes and gets it done. So when you go this route with a good design, you can increase your performance significantly. At the same time, SQL injections go away. Now, I know that this is in the what hackers like because it is still something that's very prevalent. It's still something that's very simple to do, and it does exist in medium to small businesses. I'm sure there's a lot of questions, so I'll try to finish this up. Parameter validation, still key. It's as simple as this: cross-site scripting, buffer overflow, SQL injections, XML injections, one-up attacks. We've all seen the numbers in the URLs where you change the number, hey, you look at someone else's data, you get someone else's information. These type of things are the easiest to protect against. It's an authorization check. It's a line of code that says, if the string length is greater than this, return false. Throw an exception, do something. These are the easiest things to protect against. So do them. And the moment you do them, you're going to force hackers to go to replay, to hijacking. That's where they're going to go. This is what's on the mind of hackers. This is what they see. I talked to a guy who uses Secure Shell 2.0 here recently, and I said to him, well, has anyone here used Secure Shell 2.0 specifically? Yeah. And it's interesting, it'll come up, and when you connect to somewhere else, it'll show you, it'll say, yeah, this is the certificate or the signature of the place where you're going in an attempt to stop man-in-the-middle attacks. Now, I don't have any statistics on how often man-in-the-middle attacks happen. Does anyone here? How many times have you connected to your web server, you get your nice little icon down below that says you're in SSL? How do you know that you're connected to that guy in SSL? You've got 15 hops between you and that server. You could be connected to SSL to any one of those people in between. They might be man-in-the-middling your connection, and you don't even know it. SSH 2.0 attempts to stop this by saying, every time you connect, here is the here's the certificate, basically, of where you're connecting from, and then it shows the one you have. Here's the one you have from that person. Are they the same? Should you trust this person? How many people here, when you see a nice certificate window pop up, do you just say, yes? What if it actually said, Microsoft Corporation? What if all of the text was filled out right, but it wasn't a right certificate? What if someone spoofed that? Would you say, that's weird. I already always trusted Microsoft. This is kind of odd. I think I'll call them up or look at the certificate and validate it. How many people here think that the general public does that? Anyone? Do you think they just say, okay, yes, trust that? Poof, now you have man-in-the-middle, and the hacker now also has a certificate on that client's machine. He can now man-in-the-middle that person to any server they go to from now on. The purpose of all this was just to say that in the case of the SSH 2.0, I said, well, does it ever happen? Do you ever see that? He said, it's not rare. You do see it. You go out and it says, oh, you're connecting to this certificate. And he's like, no, I'm not, because he knows what the right one is. So man-in-the-middle attacks, replay, and hijacking, they are what people are doing. It is something that is key today. So those are some ways to actually protect against that. All right. Why authenticate when you can hijack? Guess what? Why would I even try to brute force your password, etc., when all I have to do is enter some cross-site script, poof, get your session ID, go in? It's easier, it really is, than trying to actually hack directly. Sign code, encrypt data, or else. Always remember that if you encrypt something, you know it hasn't changed if you decrypt it. You can use encryption as a way to not only hide data, but also to minimize the performance degradation of doing validation of these things. Server-side security is much better with .NET. It's very easy to make sure that you're not Trojan, to detect these things, to communicate between your different tiers securely with encryption, XML, signing things. If I had a whiteboard, I can draw up about 1,000 things, and you would say, where does my application go? Where does .NET Server go? Because there's so much security that exists there. And when it's all done and said with, if your risk is, okay, my risk management is, I don't worry about it. I have this much money. I have all the time in the world. I'm going to put all of the security I can possibly put in there. You do everything that I tell you you should do for security reasons. Where are you vulnerable? Does anyone know? Your server, everything's secure on your server. You have the best authorization. You've got everything going for you. Where are you vulnerable? People? And what specific person? Your client. The client that's at home, that's a remote accessing in, that on one side is using a file sharing program, and on the other side is entering his password into your server. The client is the focal point of where hacks, once all of this can be completely secured in .NET, once you do all this, the attacks will be pointed at your clients, which is why you actually need to very specifically encrypt the data you store there. The cookies you need to validate against the man-in-the-middle attack, against replay and against hijack, is because the hackers are going after clients. The middle to small business companies, you can SQL inject them maybe, you can go after them, gain some territory, gain some power. But the moment you look at, say, Microsoft, for example, there's not very many hackers that are going to say, I think I'm just going to attack Microsoft.com directly. I mean, there's actually no purpose in actually trying to do that. Hackers today, the criminal mind, the intent is, if I can get on this person's box and he doesn't know it, he's running XP, he doesn't know anything about security, he's running the latest, greatest thing, there's all this functionality there. If I can get in there and stay there, then I'm going to be able to gain access to potentially his credit card information, so on and such forth. I'll quit beating that tree, but understand that that's where the security vulnerabilities are going to be. So the security awareness, when you start implementing, when you push the hackers out of your servers, when you push them out, you're pushing them to the clients. Does anyone have any questions? Yes? They are a part of the .NET runtime. The question was, are the cryptographic functions that you can call within .NET part of the runtime? Is that correct?
Yes.
And the answer is yes, they're all a part of that. They're crypto service provider, stamp of approval. They are very much the latest, greatest thing. There are, I believe it's pronounced Rindell, the advanced encryption standard, current advanced encryption standard, widely accepted. That is also in there. So you can use the latest, greatest crypto, and it really is fast and easy to use.
That is separate from the crypto library.
It is separate from the crypto API. Now you can, obviously, you can just use the interoperability and use crypto API should you need to, but I would suggest using the cryptographic namespace. Yes?
If I don't even have any HTML tags, but can I safely use server.html encode to avoid cross-site scripting that way?
Server HTML encode is only going to encode, don't have my list, less than, greater than, ampersand. Basically, you can still do cross-site scripting even though you're using HTML encode. Depending on the situation. I mean, obviously, it's going to actually, encode specific characters, so that may cover all the vulnerabilities. I would be very certain in your case that it is covering all the vulnerabilities of characters that you allow.
It just seems better if you don't have to do string replacement for scripts specifically. If you know that you care about HTML tags, you just either wipe them out by doing a regex replace.
Right. Another thing about HTML code and regular expressions, do not fall prey to the once again, the design or the logical sense of, I'm going to create, how do you say it? I'm going to create, one thing that happens often is you have like a less than script greater than. And you say, I want to remove the ability for someone to input that. So we do a regular expression and we take out the less than and the greater than, right? We remove that and we go on our merry way. So I, as a hacker, enter less than script, greater than, greater than. What happens? Your regular expression, well, it strips the ones off the end, and then it goes in its merry way, and I still have my cross-site script. I'm sorry? Be very careful, because depending on the syntax of how you actually use regular expression, it's not going to remove. Yeah, very much test it. Cross-site scripting is very, very, very hard, and I would honestly suggest to anyone to actually change your design, probably if you have to do massive testing in that area. So, any other questions? Is there anything that I said that people would like in more depth? I have a ton of stuff that I can go over. So, a better example of XML injection. A good example would be you make a request from a server, and the server gives you, and on the client you're going to create an XML document. So it gives you your page. You say, my SKU is going to be this. You're looking at a price. Maybe you do a lookup and you get back a product, and it itself is an XML form. And when you say, yes, purchase that, or update my shopping cart, or something like that, it creates and sends this document out. So in a case like that, let's say you decided to change the price merely by saying, as your input, and depending where they're ordered inside of the document, you could say less than price, greater than, and then go on your way, and then enter the SKU later down here. So you're actually entering tags into the edit control yourself, and based on the position inside of the XML document, when the server goes to actually process that, then depending on how the server processes it, is it a while loop while all these SKUs are in here, while there's this many tags, their position in the file, etc. That will determine whether that could be used to, say, change the price of an HD TV to 25 cents. It's been done. Things like this have been done. So
contrary to people rejection that there's any mitigation factor, what could be a mitigated factor for rejection?
what could be a mitigated factor for XML injection? You mean to pretty much just obliterate it, get rid of it, or the problem, or do not allow any HTML inputs? Because I mean, the moment you allow an image, how many people here have something where you can allow an image? Upload an image? Has anyone ever seen it? You have your image in brackets, and source equals JavaScript colon your JavaScript. And guess what happens? If you have your images on auto load, you go to the web page, before you even get the content, that script has already executed and done bad things. Maybe sent your session ID over here. It's really hard. There's so many places where you can put JavaScript in, or any scripting language for that matter. The best way, I seriously suggest, just do not allow it. Don't give yourself the chance. Because the moment you're in any situation where you have sensitive data, you do not want to be responsible for saying, well, we didn't know about. Remember that the due diligence is important in negligence. You can't really claim that. There's a new vulnerability out. Something you are not parsing for in a cross-site script, you don't see. Someone uses it, insert script. Hijack someone's session. They go in there. They're looking at credit card information. They use someone's credit card, etc. Let's say you have a great auditing process. So you actually catch this, and you report it, etc., etc. I mean, it's pretty scary when you start thinking it, in that means. Credit card information, it lasts for, 4 years, 3-4 years. So when you protect that information, basically you need to think of it, the sensitivity of the data needs to be equal to the amount of time it's going to take to break in. That really is a good thing. So if you have credit card, you should encrypt it. You shouldn't store it plain text in your database. And with that, Any other questions? Yes? Sure, I'm sorry. The question is to explain cross-site scripting. What happens is you have an input field. A server offers you, says, give me some input, and I'm going to store it. A good example is a message board. I'm going to store that in a database, and I'm going to display that to another user. And this is really key. So you insert script code instead of regular text. The idea is that the server, it doesn't validate that. So it stores the script, literally, word verbatim, into the database. Another user comes along and then sees that on the message board. When they go to the message board, there's the scripting code. If it's in a place where it actually will execute, sometimes you'll see it as a link where it'll say, click me. We're like, OK, and you click it, and then it executes. There's many ways by which it can be executed. But then it's displayed to other people. Those people then execute the script by clicking on it or through the image JavaScript source ability. And then at that point in time, your script, which can take control of the entire browser, it has access to all of the cookies that exist. It has access to your session ID, et cetera. You have that power. You're executing that code on that client. So imagine that it's a message board. Poof. All of a sudden, 1,000 people get exploited by that one piece of information that you entered, and it could be a publicity nightmare, especially in the case of sensitive data. Yes.
You talked about things that hackers like and dislike about
Mm-hmm.
application development. In your opinion, should hackers be excited or dismayed as people start to take up development?
The question was, should hackers be excited or dismayed about .NET and going on with that? I would say from the point of the type of exploits that we've seen lately with worms and then just the I'm going to go hit the server and take it down, etc., Trojans, I think that world is really in the future with enough adoption of .NET methodologies and adopting the signing of the assemblies and things like that, you will see those go by the wayside. You're not going to be able to walk in and replace a DLL on someone's system and have them not notice. If I gained access to your system and could replace, say, shell32.dll when your computer was, let's say, just not in Windows because you wouldn't have access to it, but I replace that DLL, you turn it on your system. How does Windows know that that file is that file? Version info, file size, the fact that the APIs are there, that it links. You can actually, right now, stub DLLs out and then have that trap all of the calls that are ever made to it. So you could replace, for example, crypt32.dll. You could replace that with a stub, rename the old one, call the old one still so everything still works. I mean, this is pretty intricate, but it could be done so that you could do that. With signing of assemblies, it's not possible. You wouldn't have that ability. So you remove a lot of the ability to Trojan systems and et cetera. And one interesting thing that has been done with XP and 2K is that the attempt for the operating system to say, no, these are system files. You shouldn't touch these. You shouldn't look at them. You shouldn't mess with them. You don't need to worry about them. When you get to a point where all of that is eventually signed, you really do have this global assembly cache. You have a place where all of that code can't be touched. It's digitally signed. There's public signatures. You can validate every EXE cryptographically on a system, which could be used for version control, et cetera. .NET, when you use all these facilities, gives you a lot more power, which is why I say that the hacker is going to jump into, will attempt more so the text style exploitations that exist. And from that, because those are going out, and then they're going to jump into hijacking and replay a bit more and going after the clients. For the hackers, their mentality is going to be kind of okay, our target has changed. They're not going to necessarily be dismayed by not being able to go after servers. They're just going to change their target. It's going to be good for the security world, companies at large, e-commerce, et cetera, et cetera, et cetera, that the servers and the mainstay of security in those arenas exist. And I think the more that security goes on, then you have the corporation here, which has put a foothold in security and begins to expand out. And the moment that type of security reaches, after September 11th, we have federal packet sniffers and ISPs, and there really is a large security of information that being passed around and where that exists, and forensic work as well. So I'd say that as time progresses, .NET definitely makes a hacker less excited about going and hitting a server or trying to make that quick score or doing that thing. But at the same time, it really is security in general as well along with it, that just more people are watching, more people care. It's going to be harder for hackers to get away with things like this. Does that answer your question?
It seems like a lot of the controls that you talked about with the .NET, that's going to help the security community or for small and medium businesses. But what do you see from .NET assisting those enterprises where the server ratio might be like 2 to 600 servers per app?
Well, when I say medium to small business, I was actually more talking about that .NET, because of the ease of development, offers more dangers to the medium to small business because it's just easy to get going and we didn't think about security. As far as
Somebody just pointed out there that your selection of
With current processes, I agree. It probably isn't feasible to do the code signing. Maybe it really would depend on what your process is, but I would submit, because some corporations actually have through the build process, that there is a central location that this company, or not company, but this product group and all these product groups will submit to a single place, say for performance testing or so and so. Larger companies have a lot more of the backbone and the ability to actually do a centralized key signing of these the signing of assemblies, performance testing, all the things that they would do in one place to make sure the quality control of their software. So I kind of think for large corporations it would be easier to apply these than it would for the medium to small company, which is why I think that they will not necessarily suffer more, but why it needs to be made more clear to them. Yes, it is easier development, but security has not strayed. You still have the same problems. Does that answer your question, or? You sure? Okay. Any other questions? Yes.
I'm still worried about external injection. Now that everything's going to be .NET, so you have web forms and they're going to communicate using XML. So you said that someone can put something in a web form, like XML tags, and send it back to the server so the price reflects.
Mm-hmm.
So you said that we can mitigate these.
There's some general rules. Oh, sorry. The question was more specific. What way is there to mitigate the problem of XML injection, given that with the .NET we have specifically SOAP, and we have all these things where XML is just being transmitted everywhere. What I would suggest is that you never trust anything from a client. So you never tell the client, hey, this is what the price is going to be, with intent of pulling the price back from the client and using it. That's a design flaw in the first case. But specific to XML injection, you'll pull that back, and you should still validate the fact that it is the same. So when you send something off to the client in such a way, if you can package it so that all of this should be the same and this tag should be different, then that gives you a way to do picture comparisons and say, this is what I'm expecting, this is what should have changed, wait, there's an extra tag. There's some very simple things like that you can do. In a large company scenario where, let's say, you have 600 servers that are out there, there's a large farm, and you have all these other businesses, perchance, that are coming in on a different tier than the customers, because you have business-to-business relations, and that is a big thing with .NET. And you have web, data, or XML data that's being actually sent back and forth. And that is probably one of the most important places where you must have specific encryption in tags and actually signing the XML document, and also your picture comparisons to make sure that fields that are transmitted merely for display are different than ones you get back specifically for input, etc. It really adds a whole new level of type of management to XML data itself. And it's nice because .NET really does offer a lot of XML helper functions, etc., to allow you to manipulate it and do those type of things. Does anyone else have any more questions? Okay, well, we're 5 minutes to noon, to lunch. You're welcome to go if you want, and I will be around if anyone has any other detailed questions. Thank you.